Section 3.2, proving lines parallel. The next slides are going to be the converses of the previous section's theorems and postulates. Recall, if I'm given a conditional if P, then Q, the converse would be written as if Q, then P. So in the previous section, we had if lines are parallel, then the angles would be congruent or supplementary. In this section, we're going to have if angles are congruent or supplementary, then the lines must be parallel. Let's start with the converse of the corresponding angle postulate. And here this states if corresponding angles are congruent, then the two lines cut by the transversal are parallel. So in the diagram, I'm given that I have line P and Q and a transversal intersecting those two lines. Angle 1 and 2 can be identified as corresponding angles. And if these are congruent, then I can state by the converse of the corresponding angle postulate, if angle 1 or 2 are congruent, then line P is parallel to line Q by the converse of the corresponding angle postulate. The next slides are going to be very similar to the previous theorems. Here we have the converse of the alternate interior angle theorem. If alternate interior angles are congruent, then the lines cut by the transversal are parallel. Again, we have line P and Q. Here we can identify angle 1 and 2 as congruent, and they are also alternate interior angles. Therefore, by this theorem, if angle 1 is congruent to angle 2, which means alternate interior angles are congruent, then the lines P and Q are parallel. On this slide, the converse of the alternate exterior angle theorem. If alternate exterior angles are congruent, then two lines cut by the transversal are parallel. Here in the diagram, again, we have line P and Q intersected by a transversal. I can identify angle 1 and 2, which are congruent, as alternate exterior angles. Therefore, by the theorem converse of the alternate exterior angle theorem, if alternate exterior angles are congruent, angle 1 and 2 are congruent, then lines P and Q are parallel. Our last, the converse of the same side interior angle theorem. If same side interior angles are supplementary, then the two lines cut by the transversal are parallel. Again, in the diagram, I have line P and Q intersected by a transversal. I have angle 1 and angle 2 that are known to be supplementary. Therefore, by this theorem, I can state that line P is parallel to line Q. In the diagram, determine which lines or segments are parallel. If they are, then justify your answer. Here, I have two angles, 45 and 135. They are same side interior angles with D as the transversal, because remember, a transversal must help form both of my special pair of angles. And the other two lines are A and B. And from the previous theorem, I know if same side interior angles are supplementary, then the two lines that help form them are parallel. And here I know that 45 and 135 are equal to 180 when I add them. Therefore, A is parallel to B by the converse of the same side interior angle theorem. In the diagram, determine which lines or segments are parallel. If they are, justify your answer. In this diagram, I have angle D and angle C that are both congruent. They both equal 103 degrees. They are alternate interior angles. DC is the transversal. That is the line that helps form both angles. The other two lines that form them are AD and BC. And by the converse of the AIA theorem, if alternate interior angles are congruent, then the two lines cut by a transversal must be parallel. Again, in the diagram, determine which lines or segments are parallel. If they are, justify your answer. I have angle DAB and angle EBC that are congruent. A transversal is a line that helps form both of those special angles. That would be line AC. The other two lines that help form them are AD and EB. And these two angles are corresponding angles. Therefore, the converse of the corresponding angle postulate, if corresponding angles are congruent, then the two lines cut by the transversal must be parallel. Again, they want me to determine which lines or segments are parallel and justify the answer. I'm given two congruent angles. I know they're alternate interior angles because my transversal is BD. The other two sides that help form those angles are AB and DC. By the converse of the AIA theorem, if alternate interior angles are congruent, then the two lines cut by a transversal must be parallel. Again, in the diagram, they want me to determine which lines or segments are parallel and justify your answer. Let's start with these two angles. I have a transversal. It's the line that helps form both the angles. That transversal is segment BC. And I know that 48 and 132 add up to 180 degrees. The other two lines that help form those angles are AB and DC. If same side interior angles are supplementary, then the two lines cut by the transversal are parallel. So this is converse of the same side interior angle theorem. I'm given another set of angles. I have a transversal, which is DC, and I know that these are same side interior angles, but 132 plus 45 does not give me 180 degrees. It gives me 177 degrees. Therefore, these two angles right here are not supplementary. Therefore, I cannot justify that AD and BC are parallel. I do know that DC is my transversal for those angles, but I can prove nothing else since the angles are not supplementary. In this example, in each exercise, some information is given. Use information to name the segments that must be parallel. If there are no such segments, write none. Here I'm given angle 2 and angle 9. The first thing I need to do is to determine if there is a transversal. And in this case, it's the segment that helps form both those angles. FB is my transversal. That makes these two angles alternate interior angles. And the other two segments that form them are AB and FC. By the converse of the AIA theorem, these two segments are parallel. Next, angle 6 and angle 7 are congruent. First, let's determine if there's a transversal. Our transversal is EC, that helps form both angles. The other two segments that form those angles are AE, or I also could say FE or EF. AE and BD. And by the converse of the AIA theorem, if alternate interior angles are congruent, then the two lines cut by the transversal must be parallel. Next, the measure of angle 1 and 8 are 90 degrees. First, we must identify a transversal, that is AE. The other two lines that make up those angles are AB and FC. These two angles are corresponding angles. They are congruent. So if corresponding angles are congruent, then the two lines cut by a transversal must be parallel. Angle 5 and 9. Angle 5, angle 9. The transversal is FC. Angle 5 and 9 are congruent. They are alternate interior angles. Therefore, line FB is parallel to line EC by the converse of the alternate interior angle theorem. Angle 5 and angle 2 are congruent. Angle 5 and 2 do not have a segment that forms both of them that is common. BC intersects each vertice of the angles, but that doesn't help form them. I could actually eliminate line BC and BD, and those angles would still be there. Therefore, these are not special angles formed by a transversal and two other lines. Therefore, the answer for this would be none. 3 and 11. Angle 3 and 11 are congruent. They have a transversal, which is FB. The other two lines that help form them are AE and BD. If corresponding angles are congruent, then the two lines cut by a transversal are parallel. The measure of angle 1 equals the measure of angle 4, and these are both 90 degrees. Angle 1 and 4 are congruent. They're both 90 degrees. There is no transversal that helps form both of these angles. Since there's no transversal, I cannot relate them to any of our theorems in this section. Therefore, our answer is none. Angle 10 and 11 are congruent. Angle 10 and 11 we know from previous sections as vertical angles, and we know vertical angles are congruent. And vertical angles are formed by two lines that intersect. Therefore, I can say nothing about parallel lines. So here, again, none. Continuing with this example, I have the measure of angle 8 plus the measure of angle 5 plus the measure of angle 6. 5 and 6 put together, and 8. These angles form supplementary angles. They add up to 180 degrees. There is a transversal. It is segment FC. The other two lines that form those angles are AE and BD. If same side interior angles are supplementary, then the two lines cut by the transversal are parallel. The measure of angle 4 equals the measure of angle 8, and the measure of angle 8 equals the measure of angle 1. Let's begin with the measure of angle 4 and 8 being congruent. There's a transversal. It is FC. The other two lines that help form those angles are AE and BD. If alternate interior angles are congruent, which angle 4 and 8 are, then the two lines cut by a transversal are parallel. Let's take a look at the other pair of angles, 1 and 8. Those two angles are congruent. There is a transversal. It is AE. The other two lines that form them are AB and FC. If corresponding angles are congruent, then the two lines cut by a transversal are parallel. Angle 1 and 4 do not have a transversal between them. Therefore, I can relate no theorem in this section to parallelism with those two angles. The measure of angle 5 and 6 equals the measure of angle 9 and 10. The transversal is FC. The other two lines that form them are AE and BD. If alternate interior angles are congruent, then two lines cut by a transversal are parallel. The measure of angle 2 and 3 added together equals the measure of angle 4. These two sets of angles do have a transversal, but they are same-side interior angles. Same-side interior angles to create parallel lines must be supplementary. They are not telling me that they are supplementary. They're saying that they are congruent. Therefore, each angle could be 60 degrees and 60 degrees. So this whole angle together could be 60. This whole angle together could be 60. That would give me 120 degrees, not supplementary. Therefore, I can't prove in every situation I could create same-side interior angles that are supplementary. So therefore, my answer is none. The measure of angle 7 equals the measure of angle 3, which equals the measure of angle 10. Let's start with the top set. 3 and 10 are alternate interior angles. They have a transversal of FB. The other two lines that form them are AE and BD. And if alternate interior angles are congruent, then the two lines cut by a transversal are parallel. Angles 7 and 3 do not have a transversal between them. Therefore, I can relate no parallel lines between those sets of angles. But angle 10 and 7 are congruent. There is a transversal, that's AE. And the other two lines that form them are FB and EC. If corresponding angles are congruent, then the two lines cut by a transversal must be parallel. 7 and EFB. Those two angles do have a transversal. It is FE. The other two segments that help form them are FB and EC. If same-side interior angles are supplementary, then the two lines cut by a transversal are parallel. Angles 7 and 3 are complementary, and the measure of angle 1 is 90. 7 and 3 are complementary. These two angles add up to 90 degrees. And angle 1 is 90 degrees. In this situation, 7 and 3 are complementary. There is no transversal. Angle 1 and 7 do have a transversal, but we don't know if they add up to 180 degrees. And they are same-side interiors, but since they're not supplementary, I can't say anything about parallel lines. 1 and 3 do not have a transversal between them. AB intersects the vertice of angle 3, but I don't need it to form angle 3. Therefore, the relationship between these three angles is none. In this example, they want me to find the value of x for which L and M are parallel. So what I want to do is assume that L and M are parallel. Then determine the transversal and the type of angles that are given to us. So here I have a transversal, and these two angles are same-side interior angles. If these two lines are to be parallel, same-side interiors must be supplemental. Therefore, 6x plus 12 plus 4x plus 8, I set equal to 180. When I solve, I'm going to simplify and get 10x plus 20. Subtract 20 from both sides, I get 10x equal to 160. Therefore, x is 16. 16 is the value of x for which these two lines, L and M, are parallel. Using the same directions, I want to determine the value of x that makes L and M parallel. Here is my transversal, identifying the type of angles I'm given. There are corresponding angles. For these two lines to be parallel, corresponding angles must be congruent. Therefore, 2x minus 8 equals 68. Add 8 to both sides, I get 76. Divide by 2, x is 38. So the value of x that makes these two lines parallel is 38.